So now we're going to talk through VLANs, which are virtual LANs or virtual local area networks. So virtual LANs are attached to switch ports on a switch port interfaces on a switch. Here's an example showing how certain interfaces are in VLAN 1, right? Others are in VLAN 2, some are in VLAN 3. So these interfaces don't have to be next to each other. This could be switch port 1, this could be switch port 23. It doesn't matter. So these interfaces don't have to be next to each other. It's all about the configuration on the interface itself that designates it to a VLAN. So notice how on command line, we went from the caret, which is user exec mode. Then we went type in enable or en as short for enable to get into privilege exec mode, which you can tell from the hashtag here. Then we typed in config T to get into global configuration mode. And from global configuration mode, we got into the interface configuration mode, where we can now apply VLAN 1 to interface fast Ethernet 0/1 using the switch port access VLAN 1 command. All the devices connected to VLAN port can only communicate and broadcast to devices in the same VLAN. For example, the laptop connected to VLAN 1 can only communicate to the other two laptops on VLAN 1. This is why they are considered virtual local area networks, because even though they're on the same switch, right? It's all on the same switch. They think they are in separate networks. So let's use an ARP request from the laptop in VLAN 1 and see how this kind of works out. So the laptop is looking for the MAC address of this IP address, 192.168.1.2. So the ARP request goes out to the switch, and then the switch needs to ask, okay, who on VLAN 1 is 192.168.1.2, because the broadcast is only going to go out to people in its own network, right? So to other VLAN 1s. ARP reply, so ARP request goes out to only the switch ports with VLAN 1 on it. And then one of the laptops on VLAN 1 is like, hey, that's me. I recognize this IP. I'm going to send my MAC address back to the switch. So the ARP reply is sent back to the switch. And then the switch updates its MAC address table and then sends an ARP reply back to the laptop on VLAN 1 that sent the original ARP request. ARP table is then updated on the laptop. So simply put, VLANs break up physical switches into smaller virtual switches, which means smaller broadcast domains. So notice VLAN 1, the broadcast only went out to other switch ports instead of going out to everybody, which would have been the case if there was no VLANs assigned. Now let's look at how these VLANs can talk to one another. Remember that VLAN networks need routers to talk to one another. In the same way, virtual LANs need routers to talk to one another as well. So here's the command line for the switch port interface here between switch 1 and switch 2. So this trunk is needed for the VLANs to flow from one switch to another, right? So at the top, we have the interface the trunk port is assigned to. This is a default VLAN that will be assigned if the port stops being used for the trunk, right? So for example, if this no longer became a trunk port, it would be like, okay, this is now VLAN 2 port. And then these are the allowed VLANs. The trunk will, these are the VLANs allowed to go through the trunk, right? So we could say if we wanted, only 1 and 2 can go through, or only 1 can go through. But in this case, we have 1 through 3. So all 3 of them are allowed to go through. And this bottom line just means that this port has been assigned as a trunk port, right? Switch port mode, trunk. Since each VLAN is basically a small virtual switch, VLANs need a router to route the data between the VLANs, even if the VLANs are on the same switch, right? So as long as they think they're on different networks, they're going to need a router to talk to the other networks. So VLANs are separated in layer 2, right? Because it's just the switch port that is separating the VLAN. But this is how we make it easier to keep track of. So normally a VLAN will segregate a network based on the switch port, but we'll try to assign that similar experience so that VLANs will be attached to subnets. So that way we can separate the network on both layer 2 and layer 3, but together, right? So it's not like you have layer 2 separated in these ways and layer 3 separated the other ways. No, let's make them uniform, right? Together. So this is why VLANs usually go hand in hand with subnets, because the subnets separate using layer 3, VLANs separate using layer 2. So let's say the laptop in VLAN 1 is trying to send data to a laptop in VLAN 3. The data will first go up to the switch. The data will then go up the trunk port to a second switch, if there's another switch there. In this case, there is. From the second switch, the data will go through its trunk to the router. The router will read the IP address and associate VLAN. The router will then remove the VLAN 1 tag, add a VLAN 3 tag, since it sees that the destination is out through the router interface labeled as VLAN 3. The router then checks its ARP table to see what the host MAC address is and sends the data back down to the switch. The switch will then see the data source as VLAN 3 and its destination as VLAN 3 with the MAC address of the laptop and sends it back down to the original switch. The original switch then uses its MAC address table to see which port to send the data to, sending it to the port the laptop is attached to. Where the laptop reads the destination IP address and goes, hey, that's me.